All right, guys, let's go through the rest of these graphs. So y equals x cubed, the cubed graph, you've got 0, 0, 1, 1. The next point is 2, 8. That's kind of off the graph up here. And then -1, -1, -2, -8. This is a very skinny graph. Okay. Tall, skinny graph. We okay with that one? All right, square root. We've got 0, 0, 1, 1, 4, 2, and then it just goes that way. Guys, that's why, like last skill, remember our domain, square roots, we had restrictions. It's because the graph doesn't cover everything, okay? It's restricted.
Can it have, can it just go down to one of
That's if it was equal to plus or minus the square root of x, then you'd have that. And then it wouldn't be a function. Okay. All right, guys, cubed root. Remember, cubed root didn't cause any sort of restrictions. But you can take the cubed root of a negative number. Cubed root of -1 is -1. You can go all the way to -8, 2, which again is like off the graph. It's as skinny as your cube function. It's just now sideways. Okay.
Wait, so why is the square root not 0?
Like down here?
Yeah, I forgot.
So that is if we were graphing negative square root of x, you'd have that bottom piece. So we don't. We just have the positive one. All right, we're okay with the first 4 graphs. See a few people writing. I'll wait a second here. Okay. 1 over x. Guys, this is a rational function. That's the thing with the asymptotes. Okay, so you have a vertical asymptote at 0. Horizontal asymptote at 0. Number of points here, I don't need a ton of points. I need like 1, 1, and then you can follow the shape of the asymptotes, and then -1, -1. Okay? Okay, step function. You guys, I don't think know this one. It's sometimes called greatest integer. We call it a step function because it looks like steps once you graph it. So if I start at 0, 0, that's a filled in dot. And then I draw a straight horizontal line over to 1, and that's an open circle. Then I go up, like I step up. Filled in on the left, open on the right. Filled in on the left, open on the right. Let me draw all of this, and then I'll zoom in a little so you can see it better. Is that helpful a little? Can you see close on the left, open on the right? That way it's still a function because nothing is overlapping with your points there. We're not going to do a lot with this, but it is a function to be aware of.
Do they not connect?
In the middle, they're connected. Yeah, it's kind of hard to see. All right, are we okay with step function? Do you have a question?
I just want to know.
So what these brackets are telling you is that you're essentially like rounding down. So if I put in an x value of 1.1, that equals 1, 1.2, 1.7, 1.9. If I go to 2, I'm at 2. 2.1 is 2. Like, you can only get integers as your output.
It's not rounded normally.
All right, absolute value of x. You guys are usually pretty good at graphing this. We okay there? All right, 2 to the x. We've graphed exponentials and logs this year already. Okay, remember we just used 2 points and then we did transformations. So for exponentials, we always use 0, 1, and then 1 comma whatever the base is. So I would use 0, 1, and then 1, 2 in this case. And I have a horizontal asymptote at 0. And then it grows exponentially.
Why is there horizontal asymptote 0?
Because it will never actually equal 0 or anything negative. Like positive 2 to some exponent, it's never going to be 0. You can get really close to it.
Or even if the exponent's 0.
Right. And if the exponent's negative, it's getting closer to 0, but it's never actually 0. All right, guys, so e to the x, same idea. You're going to use 0, 1, and then 1, the base. So the base is e. Well, what is e? What number is e? 2 points. Yeah. Well, natural log is a log with base e. They're connected. They're inverses of each other. But e is actually a number, like pi, we know 3.14, e 2.7-ish, okay? So you're going to plot 0, 1, and then 1, somewhere in between 2 and 3. I'm not going to look at that and go, no, you plotted 2.4, I needed 2.7. No, not going to be that picky. I'm just looking in between the correct integers. Still a horizontal asymptote at 0. So it looks very similar to just y equals 2 to the x. It's like 2.7. Okay, when we graph logs, remember logs are inverses of these exponentials. So if I use the point 0, 1 for the exponential, I'm going to use 1, 0. Instead of 1 base, it will be base comma 1. So 1, 0, base of 2, so 2, 1. Instead of a horizontal asymptote, what will I put? Vertical, yes.
So what's the base? Base is 2, right?
Yep.
And if it's log,
All right, what happens when it's natural log? Still 1, 0, and then base would be e, right? So 2.7-ish, 1, still a vertical asymptote. Sure. The natural log one? Yeah. Does that help? Okay.
whoa.
It's the magic pen.
That is shocking. ln is also
Yes.
the same length.
Thanks. Everybody okay?
Yeah, sorry.
You're fine.
Why am I apologizing?
I was like, I don't think you did anything. Rithik, are you good on that one? Yes. Okay. All right, any questions? Yeah. So 1, 0, right? And then what's the base on that one? What's the base in this equation? Yeah, so 2, 1 is the other. All right, guys, let's keep those phones away. I'm seeing way too many of them out today. Okay, shifting. So guys, those are the parent graphs. We're going to graph equations now by shifting those parent graphs. I think you know all of these, but I want to make sure we go through it. So f of x plus c. If you have plus some number outside of your x thing that you're talking about, what does it mean?
Upwards.
Yes, so this one is up c. What do you think f of x minus c means? Yes, down by c. All right, so f of x, this time the plus c is in parentheses. So what does that mean? Left c. What about minus c? Okay, negative out in front of your fraction, or function, sorry.
Negative c.
Okay, so multiply the y values by a negative, flip. What are we flipping over? So this is a reflection. Reflect over x-axis. Okay, f of negative x, what does that mean? Reflect over y-axis. Yes, your x is changing sign. You're going to reflect over y-axis. All right, the next one, we've done a lot with a coefficient like out in front. What does that leading coefficient do?
That's the period, right?
So you're thinking like trig functions. Yep. Yeah, so when it's just a coefficient out in front, that's just what you multiply your y values by. So it is either a stretch or compression, but on the vertical. So vertical stretch or compression. And guys, make a note. What you're doing, you multiply y values by whatever c is, okay? Read that, okay? Okay, f of c of x. We have not done a ton with this. We did do it with our trig graphs, and that's where it changed the period. That's what we were thinking about, where we would like factor it out and then relabel everything. So when it's inside with the x, it is a horizontal stretch or compression, but then there's a trick to what we're actually doing. I'm abbreviating a lot here. Horizontal stretch or compression. Okay, but what you do, you multiply the x values, not by just c, but by the reciprocal of c. So by 1 over c. If you think back to when we did it with trig graphs, like if you had a 2 as your coefficient, didn't you take the x-axis and divide everything by 2? Yeah, you were multiplying by 1 over c. Okay, so you've done it before, but you really have only thought about it in terms of trig graphs. We're going to do it with all the regular graphs now. So again, if you see that coefficient on x, think about multiplying the x values by 1 over whatever that number is. Okay? What? Horizontal.
I know it is.
Well, are you sure? Okay. Questions on the shifting? All right. Oh, go back. James? know, but put your phone away. You good? Okay. All right, I want you to try a couple of these. We'll check in, we'll do them kind of a piece at a time. Try number 1 and 3 to begin with. Just those two to start, and then we'll go through them. It is, yes. I feel like you need coffee today. Oh, okay.
What kind of music do you like?
It depends on like what I'm doing. I like lots of different things. The what?
That.
On days that it's your birthday, what do you want to listen to? I don't know. What? Why? Like, what exactly are you asking? Surprise me. Okay. Depends. Like, if I'm working out, it's one thing. If I'm driving, it's another thing. If I'm hanging out, I mean, I do like a lot of 80s stuff. Okay. A little bit, yes. I do like Hall & Oates a little bit, yeah. Check with your neighbor. Do you have the same graph? And write the domain and range for me, guys. That is on the inside. If it was a vertical shift, it'd be like, yeah. Okay. Yeah, it's got some good backup pencils going.
Not now, but I have like.
Oh, I hate the pen.
Good job. I'm gonna use this.
All right, guys, number 1, what is the shift? Down 1, right? Okay, in blue, I put the parent graph dots. You can do that if it helps you. You can use different colors. I do not care. If you don't need them, also fine, as long as you are graphing correctly. So just move each one down 1. Lots of ways you can think about this. There's your graph. What's our domain? Good. Negative infinity to positive infinity. What about our range? Good. Okay. Questions on 1? Tyler, you got it? Okay. What's happening on number 3? Right 2. So I go 1, 2, and then I just graph my square root function from there. 1, 2. That's it. So domain is bracket 2 to infinity, range 0 to infinity. Questions? We okay?
Why is that the 2 isn't the domain?
For number 3. So if I look at the graph and I go from the left to the right, where does it start? That is why. Oh, you want me to fill the rest in before I post it? Is that what you mean? I was just going to use the one I do here and print this to a PDF, but I can fill in the others.
Yeah, but I just need like a visual.
Something to reference. Yeah. Yeah. Sure. All right, guys, try number 4 and try 6. We're jumping around a little. Guys, I'm just filling in the other ones that I'm skipping. But do 4 and 6.
How do you graph?
6 is kind of weird. Thank you. Did you get one of these? Nope, that's all we did. Try 4 and 6.
Oh my gosh.
You can do 6. Do you know what 1 over x looks like? Okay, where is it shifted? Are you okay, Manny? Are you on 6? Okay. You know 1 over x, right? Where's it shifted? Which way? The asymptote moves, like the whole thing just... Then you draw it. Yeah. It's easy. In reference to the asymptotes, yeah. They like all shift. If there was a negative, yes, because you'd be... But yeah. Don't overthink it.
Oh, that's already happening.
Is that your specialty?
Yeah.
Yeah. The asymptote would also move. Like it all moves, whichever way it's going. But this one's not going up. Which way is it going? If it was going to go up, it'd say like +4 out here. For number 4? Nope, it's with the x. If it was going to be a vertical, like if it looked like that, that'd be left 4 and up 2. Okay. Yeah. But again, the asymptote goes, yes, everything moves. Don't leave anyone behind, okay? How to what?
I don't know what it is. Wait, I don't know. I know what it is.
Yeah, you just shifted on
You should, yeah.
I think that's what that's what we should do. It's just like
All right, guys, let's look at 4 and 6. Hey, guys, up here. The range is a little weird with 6, so I want to make sure we talk about that. Number 4, that is a shift left 4 when it's in the denominator with your x. If it was going to be a vertical shift, it would be something like +2 outside of the fraction. So in the denominator of your fraction is a horizontal shift. And then it just all moves to the left. Asymptotes, points, everything. Shift it, graph your parent graph from there. Domain, negative infinity to -4, -4 to infinity. Range, you're skipping over 0. So negative infinity to 0, 0 to infinity. Yeah. So guys, 6, that's just the step function shifted right to. So it's not that hard to graph. You just move it over to. The asymptotes on number 4. Yes. Yeah, they go too. Don't leave them behind. Otherwise, you then have an asymptote and your graph going straight through. Yeah, doesn't work. Now, guys, the domain of that is actually all real numbers. It's like chunked up, but if you think about it, every x value gets used. Okay? The range, it's all integers. Okay? You know how we have the weird R for real numbers, right? Like, this thing means all real numbers. That Z means all integers. If you just tell me the range is all integers, I'm fine with that.
How do you write that? What does that mean? Y, find Y, E?
Y such that Y is an element of integers. Remember we did like for our domain X such that X is an element of the reals, but X cannot equal 2/4, right? We did that. Okay. Same thing but with a Y. All right, questions on 4 or 6, other than I just don't like the Z.
I don't like this.
I said other than that.
Oh, sorry.
Okay, let's do 7. Again, guys, you can just write for the range all integers. Okay. If you're taking calculus, weird symbols like that will show up more and more often. So. Do number 7 for me.
Yeah.
Maybe some that's. That's wrong.
Uh-oh. You grabbing a parabola there? Thought I heard a 2-4 in there before it was supposed to be a 2-4. All right, guys, number 7. -2 absolute value of x. What is that -2 doing? And stretching, yes. So 0, 0 is still there. Instead of 1, 1, I'm going to have 1, -2. Instead of 2, 2, 2, -4. Your domain, all real numbers, -infinity to infinity. What's the range of this one?
Bracket 0.
That would mean 0 and up.
Oh, to negative, I agree.
Okay, can we go from +0 down to -infinity? Or how should I write it?
Anything possible.
Yeah, always go in order from bottom to top. So -infinity to 0.
Is it bracketed?
It is a bracket, yes. Okay, how we doing? Pushing through. Guys, we haven't seen any yet that have like a stretch and a shift. What order do you need to do those transformations in? Yep. Yeah, think about order of operations. You'd multiply before you would add or subtract. Okay, so multiply, do your stretch, flip, all of that, then do the shifting, whatever. Yeah, it doesn't always match up though. Yep. Awesome. All right, turn the page, guys. Yep. All right, guys, 11, 13, 15, or I'm sorry, 16. 11, 13, 16. Do those 3. Man, I cannot talk today. Yep, 11, 13, 16. Try those 3.
Okay, so if it's
I'll be right back.
multiplied by the 1 pound.
11, 13, 16.
Yeah, you might want to go get
Good. Thank you. That's how you go. Something else going on.
How we doing, guys? Got all three done?
Hey, let's go. All right.
You can do it. All right, guys, if you're not quite done, let's go back and go through these together. So everybody look at number 11. All right, so we've got y equals 2x cubed. Do you guys see how the 2 is inside with the x? Okay, I'm going to put the parent graph dots. There's multiple ways you can do this, but I just want to show you what's happening. And then this was like way up here. Okay, when it's inside with the x, that's a horizontal stretch or compression. What do I do? What am I multiplying the x values by? 1/2, yeah. So 0, 0 is going to stay the same. 1, 1 is now going to be 1/2 1. Okay, it gets smushed in there. What about 2, 8? What is that going to be now? 1, 8. Yeah. Now, if you're struggling with that and going, what am I multiplying by? What am I doing? You can certainly plug in an x value and figure that out as well. If you plug a 1 in, 1 times 2 is 2, 2 cubed is 8. Like, you can get there that way. That's okay. But what's happening if you're just doing transformations is you're multiplying the x values by 1/2. And so you get this even skinnier graph. It's really hard to draw. Domain, all real numbers. Range, all real numbers. Questions on 11? You see it? Okay. 13 was probably easier for you. You're just shifting right 2, up 4. Draw your absolute value graph from there. Is that one easy? Okay. Domain, all reals. Range, bracket, 4 to infinity. Anybody questions on 13?
What I did first. Don't have to value x plus 2 plus 4. X plus 6.
No. This is not x plus 2 plus 4. It's not a plus, it's a minus, and the 4 is not in the absolute value. So you got to look at that as two shifts. Right 2, up 4. Algebraically, you can't like move something outside of the absolute value inside the absolute value. It doesn't work. All right, 16. Guys, what are the 2 points I would start with my parent graph?
1, 0.
1, 0. So in this case,
It's 2. Or 2, 1.
2, 2, 1. Okay. So I'm just going to put kind of little dots there. 1, 0, 2, 1. Where am I going then? Left, 2, down, 3. So I just count 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Where's my vertical asymptote? -2. There we go. Domain parenthesis -2 to infinity. Range all reals.
Oh.
Okay.
Happened.
Move that up a little for you guys. Up to 13. What?
You go like up to 15.
So I'm going to post all the others filled in. You were only supposed to do 11, 13, and 16. Okay. Do you have 13?
Yeah.
Okay. I'll post the rest on Schoology. Yep. Questions on 16? Again, guys, that should be review. We've already done that this year. Okay? All right, turn the page. Rich, come. All right, number 1. So you don't have to graph now, you're just writing the equation. So f of x equals x. We're starting with the most basic linear function. We're going to shift 7 to the right and down 1. So you can just write y equals, you can write f of x equals, I don't care over here. Make sure it's an equation though. So if I want to do 7 units to the right, what does that mean goes in the parentheses with my x? Okay. And then down 1 unit? -1. Now guys, since this is a line, you also could have just said y equals x minus 8, and that would be the same graph, okay? But this shows that you've separated out those two transformations. Make sense? It's almost weirder when it's just a line. All right, we've got a parabola for this next one. Your quadratic. Y equals, shift 5 to the left. How do I show that? Okay, so I'm going to have x plus 5 in parentheses, square that. Okay, plus 4 outside, and then how do I reflect over the x-axis? Yep. There we go. We'll just keep going through all of these together. You're welcome. All right, so 3, you've got absolute value. So y equals, all right, I want 3 units to the right. So in the absolute value, what am I going to write? X minus 3. Down 2. -2. Reflect over x-axis. Negative in front. Okay. Next one, we've got a square root function. Y equals. So inside the square root, x what? Plus 6. Then up 3 units, what does that mean? Yeah. And stretch vertically by a factor of 2. That's 2. Yeah, on the outside. There we go. All right, we're doing our cubic, x cubed. Y equals, what goes in the parentheses with the x? Nothing. So I've got x cubed. And then what? Plus 5, and you don't have to put your x in parentheses. You can just say x cubed. Okay, compress vertically by a factor of 3/4. What does that mean? We don't need a negative because that would flip it. If you just put a 3/4 in front, that is a compression. So it just means multiply the y values by 3/4.
Just put a bracket on the whole equation, or you just.
Nope, it's just on that first part. Just like the one before, where we stretched vertically by 2. See how it was just in front of the square root? Yep. Same thing. All right, now we've got our cube root function. So we're going to shift 8 to the right. So y equals cube root of what? Okay, so this is a tricky one. So we've got x minus 8. And then what's the other transformation? Okay, so negative, not in front, because that would reflect over the x-axis. So 2 ways you could write it. You can put this in parentheses and stick your negative in there. Or you can do cubed root negative x plus 8. Okay, it's tricky. Because you need the shift to be to the right by 8. Okay, so that can only happen if you either distribute the negative or factor it out. Okay? All right. Absolute value function with a vertex at negative 3, 2. What does that actually mean that we're doing? So it's going to be left 3, right, and up 2. So how do I do that in terms of? Yep, x plus 3 inside, plus 2 on the outside. Guys, did you get number 7? All right, then what's the equation going to be for number 8? Julian, please. Yep, x minus 1, quantity squared, minus 4. Stop there for a second. Are we doing okay? Guess we're not doing okay. Questions through 8. All right, number 9, a linear function whose 0 is 5. Guys, if your 0 is 5, is that the y-intercept or the x-intercept? It's your x-intercept. So this means you have a line that crosses the x-axis over here at 5. So what would you tell me your equation is? X minus 5. So that's the same as the y-intercept being negative 5, which works. All right, guys, last couple here will make you think just a little bit. We've got an absolute value function. The range is from negative 3 to infinity. Yeah, that's all that means, right? Down 3. So I've got y equals absolute value of x minus 3. Last one, your range is negative infinity to 4. You are flipping it. And then going where? Plusing 4, yes. Plus 4. Okay.
Because the negative is not attached to x.
It's not in the parentheses, no, because that would change it. That'd actually make it a positive. Squaring negative, yeah. This is saying the opposite of whatever you get.
Like this to this, right?
It's making it go this way.
Oh, wait, if you wanted to flip it higher,
Yeah, and if you have a parabola that's slipping over the y-axis, do anything. Yeah.
That's what you would do.
2, sure. Got it? Okay. All right, guys, that is the end of your notes. Do you want a quizzes or do you just want time to work on Delta Math and get it? Okay. All right, Delta Math is up. It is graphing on Delta Math. It's not that bad. There's one point that the green dot in the middle of your graph does all the like shifting up and down, and the blue dots on the graph are how you stretch and compress or flip. Okay, you'll see it. You'll figure it out. Guys, I will be checking on your progress on your Delta Math. So ready to go. Yes. Krish, find a way.